AST 2.6. I can predict the position, velocity, acceleration, and time of an object or event using relevant calculations. Learning target AST 2.7. I can use computational reasoning with the patterns in motion to describe and predict the motion of an accelerating object with an initial speed. So, in this learning target, these equations are very important to solve motion problems. Now, in these three equations mostly are used. You're not really supposed to use these equations for an hour unit. So I'll run you through these equations. So here is VF, which is the final velocity, equals VO, which is the original velocity, plus AT, acceleration times time. Here is distance equals VOT plus half AT squared. And then you have D is equal to DO, original distance, plus VOT plus half AT squared. Now, these equations are derived from here. And you actually, in the test that we had to take, we actually had to only use these equations because these equations weren't really relevant to what we were doing, because you needed all of these. But if you can use these equations actually anytime, but I think you actually only need these equations when you're either missing a variable, such as, let's come to this equation right here. D is equal to VOT plus half AT squared. Let's say you're missing A over here. So then we go back over here. D is equal to half AT squared. You're missing A, right? So that means you have T, and then you know what 1/2 is, and then you know what the distance is. And from finding all that, from knowing all that actually, you can find out A by putting everything on the other side and then calculating for A. Same with all these equations, because these equations are pretty much derived from these equations over here. So, once you already know these equations are already given. And then you can find out the answer or missing variable. Okay, so in this learning target, here are some key vocabulary words that you need to know. Here, velocity. So velocity is the rate of change in an object. So it could be like constant velocity, right? So it's like, just how much. So between each interval, what was the difference of that? So did you increase your speed or did you decrease your speed? And then acceleration. So acceleration is when it's the rate at which the velocity moves over time. So that means when the object starts moving. So that means in an acceleration case, it'd either be going slow, then slowly picking up speed, or in another case, if it's going fast, and it can slow down, And the position of an object. So in this learning target, once you figure out, the acceleration, velocity, time, all these other factors in it, there's also where will the object end up. So that will also include, where the object will be. Yes. Here then time. So then time is how, after what time, where will the object be? So after, let's say, 5 seconds, will the object be, at this point at this point of, the area, or, it could be over here. Where is the object after 3 seconds? Where is the object after 2 seconds? I'll also now be showing you some practice problems of involving these key vocabulary terms.